Hold a small stone in your hand. Feel its weight. Feel the rough texture of the mineral against your skin, the cool, indifferent density of it. Now, open your fingers. There is no effort in this, no muscle to strain, no will to exert. You simply stop holding on, and the stone departs. It does not drift. It does not hesitate. It moves in a straight line toward the centre of the earth. This is the only law we obey by doing absolutely nothing. We spend our entire lives fighting this pull. We build chairs to keep us off the ground. We build skyscrapers to defy it. We spend an enormous amount of energy simply maintaining a vertical posture. We push back against a force that never tires and never sleeps. But in the moment you open your hand, you are no longer fighting. You are surrendering. The stone falls because it is the most natural thing in the universe to fall. It is a return, a homecoming. We think we understand this process because we have seen it happen every day of our lives. We see the autumn leaf spiral toward the grass. We see the rain strike the pavement. We see the fruit drop from the branch. Because these things are familiar, we believe our intuition is accurate. We trust our senses to tell us how the world works. But our intuition was not designed for the architecture of the cosmos. Our brains were built for a very specific set of problems. They were calibrated for the immediate and the tactile. Our ancestors needed to know if a berry was ripe. They needed to hear the snap of a twig that signaled a predator in the brush. They needed to judge the distance of a jump across a stream. This is biological hardware designed for survival, not for physics. It is an intuition built for fruit and predators. It is not built for the curvature of spacey time. To our senses, gravity feels like a pull. We imagine an invisible rope tied to the centre of the earth, tugging at everything we own. We feel it as a burden, a heaviness in the limbs after a long day, a pressure on the chest. We perceive it as something active, something that happens to us. But the reality is quieter than that. If you look closer, gravity is not a violent tug. It is not a demand. It is more like a suggestion, a patient, polite invitation for things to remain together. Consider the air around you, the oxygen you are breathing right now. It is a thin veil of gas clinging to a spinning rock in a vacuum. There is nothing holding it here but this quiet suggestion. If gravity were any weaker, our atmosphere would simply drift away into the black. The world would become a silent, frozen husk. The air stays because the earth asks it to. The oceans stay because the earth asks them to. You are staying because the earth asks you to. It is a relationship of immense scale and profound subtlety. We are accustomed to thinking of the universe as a place of chaos. We think of exploding stars, colliding galaxies, and violent voids, and that is true. But beneath the noise there is this constant, steadying influence. Gravity is the great organizer. It is the force that gathers dust into planets, and planets into solar systems. It takes the scattered debris of dead stars and folds it into spheres. It is the reason we have a place to stand. When you dropped that stone, you were not just witnessing a physical reaction. You were participating in the fundamental logic of the universe. You were seeing the smallest possible version of the same process that keeps the moon in its track and the earth in its orbit. The scale is different, but the rule is identical. We often mistake silence for absence. We think that because we cannot see gravity, it is not doing anything until something falls. But gravity is always working. It is the background hum of existence. It is the tension in the wire, the lean of the tree, the slow, rhythmic pulse of the tides. It is the only thing in the universe that never cancels out. Most forces have an opposite. For every push there is a pull. For every positive charge there is a negative one. They fight. They balance, they vanish into each other. But gravity only adds. Every atom in your body, every grain of sand on a beach, every mountain range and every moon, they all contribute to the pull. It is a cumulative force. The more you have, the more you attract. It is a slow accumulation of influence. This is why it feels so effortless when we let go. We're not initiating a movement. We're simply stopping our resistance to a process that has been happening since the first second of time. We spend so much of our lives trying to hold things together. We grip our possessions, our relationships, and our identities. We tighten our fists to keep from losing what we value. But there is a strange peace in the act of dropping. There is a relief in remembering that you do not have to hold the world in place. You do not have to maintain the orbit of the earth, or the stability of the atmosphere. The universe is already doing that for you. It is managing the distances. It is arranging the sequence. Tonight we are going to look at how this works. We will not use a textbook, but a map of our place in the dark. We will move from the simple act of a falling stone to the wider, stranger truths of the void. We will see how a man in an orchard once realized that the apple and the moon are governed by the same quiet law. We will explore how space itself can bend, like a heavy weight resting on a silk sheet. But for now, just stay with the feeling of the stone. Imagine it hitting the ground. A small, dull thud. The movement is over. The tension is gone. The stone has found its level. It is exactly where it is supposed to be. And you are here too, lying still, breathing slowly, obeying the only law that requires nothing from you but your presence. Consider a small, smooth stone held between two fingers. There is no effort in holding it. There is only the slight, constant pressure of its mass against the skin. And then there is the act of letting go. The fingers open. The stone departs. It does not hesitate. It does not search for a path. It simply descends. This is the most effortless act in the known universe. To drop something is to stop resisting. It is the only law we obey by doing absolutely nothing. We do not have to learn it. We do not have to believe in it. We only have to step aside and let it happen. Our intuition was built for this. Our ancestors developed a deep biological understanding of things that fall. They understood the arc of a ripening fruit. They understood the sudden downward plunge of a predator from a branch. This is the gravity of the immediate. It is the gravity of survival. But our intuition ends where the horizon begins. We can feel the stone hit the floor, but we cannot feel the earth pulling on the moon. We can sense the weight of a book in our hand, but we cannot perceive the invisible curvature that keeps our entire solar system from drifting into the void. Our minds are designed for the small and the fast. We are not built to perceive the slow, patient architecture of space-time. To us, gravity feels like a force. It feels like a tether. We imagine it as a violent pull, a cosmic hook that snags everything in its path and drags it downward. But that is an image born of our limited perspective. If we move away from the sensation of falling, we find something different, something quieter. Gravity is not a struggle. It is not a demand. When viewed across the vastness of the vacuum, gravity reveals itself as the universe's most patient and polite suggestion that things remain together. It is a quiet insistence. Think of the way a conversation settles when the noise in a room dies down. Think of the way dust eventually finds its place on a shelf. Gravity operates on this same frequency. It does not shout. It does not rush. It simply provides the slope upon which everything else slides. For billions of years this suggestion has been the only thing preventing the cosmos from becoming a featureless mist. Without this patient leaning, there would be no centres. There would be no gathering. The hydrogen and helium of the early universe would have continued their lonely expansion. They would have drifted further and further apart until the distance between two atoms was an impassable ocean. But gravity whispered. It suggested that a few clouds of gas move slightly closer. It suggested that those clouds, once gathered, should hold on to one another. It is a slow accumulation of presence. First, the gas became stars. Then, the left-over debris became planets. And on one of those planets the suggestion became so strong that it allowed water to pool in basins and air to cling to the crust. It created the very possibility of a place to stand. We spend our lives fighting this force. We build skyscrapers to defy it. We fuel rockets to escape it. We spend our days straining against it just to keep our heads upright. Because we fight it, we perceive it as an adversary. We see it as the thing that makes us tired, the thing that makes our joints ache after a long day. But there is another way to experience it. When you lie down at the end of the day, the struggle ends. You stop fighting the slope. You allow your shoulders to settle. You allow your breath to slow. In those moments gravity is no longer a weight to be carried. It becomes a support. It is the feeling of being held. It is the silent confirmation that you are exactly where you are supposed to be, that you are anchored to a world that is, in turn, anchored to a star. We often speak of the void as something cold and empty, a place of terrifying distance. And it is. But gravity is the bridge across that emptiness. It is the invisible thread that connects the smallest pebble on a beach to the furthest galaxy in the observable sky. It is a universal kinship. Every atom in your body is currently responding to the pull of every other mass in the universe. You are being tugged, very gently, by the mountains in the distance. You are being leaned upon by the moon. You are being guided by the immense, silent heart of the Milky Way. Most of these pulls are too small to notice. They are ghosts of forces. But they are there, constant, unwavering. This is the nature of the cosmic invitation. Gravity does not ask for your permission, and it does not require your effort. It simply arranges the furniture of the universe so that things can find each other. It turns chaos into orbits. It turns clouds into worlds. Tonight we are not looking at gravity as a mathematical equation or a textbook definition. We are looking at it as a relationship. We are exploring why anything bothers to stay near, why the earth does not simply wander away from the sun, why the atmosphere does not leak into the dark. We are looking for the logic of the lean. The universe is vast, and much of it is defined by an aggressive desire to expand. Space is stretching. Galaxies are receding. The great trend of the cosmos is one of departure. And yet, in the midst of all that fleeing, gravity remains. It is the only thing that says, "Stay." It is the quiet anchor in the sea of expansion. As we move deeper into this, leave behind the idea of falling. Forget the image of the plummet. Instead, imagine a curve. Imagine a soft, invisible dip in the fabric of everything. A place where the universe has folded itself just enough to create a home. That is where we live. In the fold. Under the patient gaze of a force that never tires and never lets go. We often confuse the two, but gravity and weight are not the same thing. Gravity is the invitation. It is the silent, invisible curvature of the world that asks everything with mass to move toward everything else. It is a constant, patient pull. It does not shout. It does not hurry. It simply exists as a property of being. Weight, however, is something different. Weight is a reaction. When you lie still in your bed, or stand with your heels pressed against a hardwood floor, you feel a pressure. You feel the heavy sink of your shoulders into the mattress. You feel the dull ache in your joints after a long day. We call this weight. But that sensation is not actually gravity pulling you down. Gravity has already done its work. It has already pulled you toward the centre of the earth. What you are actually feeling is the floor pushing back. Weight is the measurement of the floor refusing to let you pass through it. It is the physical resistance of the earth asserting its own solidity against your descent. If the floor were to vanish, or if the ground beneath you simply ceased to be, your weight would disappear instantly. You would be weightless. But gravity would still be there. It would continue to pull you, unbothered and unchanged, through the empty air. Weight is the friction of existence. Gravity is the law that creates it. For most of human history we believed these laws were divided. We thought the earth followed one set of rules and the heavens followed another. We believed the dirt beneath our fingernails was governed by a heavy, clumsy physics. Meanwhile, we thought the stars and the moon moved according to a divine, ethereal geometry. It seemed like a perfect, frictionless dance that had nothing to do with the mud of the world. We lived in the bifurcated universe, the fallen and the floating. Then came a period of profound silence in the English countryside. In the middle of the 17th century, a young man named E.Y.E. Zack No O'Tune retreated to his family home at Wulzedthorpe Manor to escape the Great Plague. He spent his days in a state of disciplined isolation. There were no lectures there, no crowded universities, only the wind in the orchard and the slow movement of the seasons. It was here, in the stillness, that Newton began to notice a pattern. The story tells us of an apple falling from a tree. The legend suggests a sudden piff, knee, a fruit striking a head, and a flash of light. But the reality was quieter. It was a question of direction. Newton watched the apple fall, and asked why it moved in a straight line toward the centre of the earth. Why did it not drift sideways? Why did it not drift sideways? The answer was simple. The earth was pulling it. But then Newton looked up. He saw the moon, a pale silver disk hanging in the blackness. He knew that the moon was moving. He knew it was travelling at a great speed, circling the earth in a perpetual loop. And he realized something that had escaped every astronomer before him. The moon was falling. It sounds wrong to our intuition. We think of the moon as floating, suspended by some celestial magic. But Newton saw the truth. The moon is in a state of constant, eternal descent. It is being pulled toward the earth by the exact same force that pulled the apple from the branch. The only difference is speed. The apple was still, so it fell straight down and hit the grass. The moon, however, is moving sideways with such immense velocity that as it falls, it misses. It curves around the earth, falling forever, but never arriving. It is a fall that never ends. This was the quiet realization that broke the world in two. Newton understood that there was no divide between the dirt and the stars. There was no special physics for the heavens. The same rule that governed a piece of bruised fruit in an English garden also governed the motion of the distant galaxies. One law, one architecture. He called it universal gravitation. The word universal gravitation, the word universal, is the weight of the thought. It meant that gravity was not a local phenomenon. It was not something that only happened on earth. It was the connective tissue of the entire cosmos. Every atom in the universe, no matter how small or how distant, is reaching out to every other atom. A grain of sand on a beach in Japan is pulling on a star in the D galaxy. The pull is twes mul. It is so weak that it cannot be felt, but it is there. It is a conversation happening across billions of light years, conducted in the language of mass and distance. Newton's math revealed a universe that was no longer a collection of separate spheres, but a single, integrated machine. He saw that gravity was the invisible thread tying everything together. The sun holds the planets. The planets hold their moons. The moons pull at the oceans. Everything is leaning toward everything else. This realization changed the way we perceive our place in the dark. We were no longer observers of a distant alien sky. We were participants in it. We are made of the same matter that obeys these laws. The blood in our veins and the iron in our bones are subject to the same pull as the collapsing cores of dying stars. We are not merely standing on a planet. We are locked in an embrace with it. The comfort of this is found in its reliability. Gravity does not fluctuate. It does not have moods. It does not decide to stop working for an hour, or change its mind about the direction of down. It is the most honest thing we know. It is a constant pressure, a steady hand, ensuring that we remain tethered to the only home we have ever known. It is the reason the atmosphere clings to the rock instead of drifting into the void. It is the reason our water stays in the basins, and our fire burns upward. It is the silent foundation upon which every other physical experience is built. When you feel the weight of your body against the sheets, you are feeling the legacy of Newton's apple. You are feeling the echo of a law that spans the breadth of existence. You are experiencing the simple, brutal fact that mass desires company. And as we lie here, held fast by this invisible grip, we can begin to wonder how this pull actually works. We can move past the what and the who, and start to look at the how. Because while Newton found the rule, he did not find the reason. He could describe the pull, but he could not explain why space itself allowed it to happen. He knew that the moon was falling, but he did not know what it was falling through. To understand an orbit, you have to stop thinking of it as a circle. A circle is a closed loop. It is a finished thought. But an orbit is something far more restless. Imagine holding a stone in your hand. If you let it go, it falls straight down. It obeys the simplest law we know. It seeks the centre of the earth. If you throw that stone forward, its path changes. It no longer moves in a line. It moves in an arc. It is still falling, but now it has momentum. It travels some distance across the grass before the ground eventually catches it. Now imagine you could throw that stone with impossible force. You throw it so fast that as the stone falls toward the earth, the surface of the planet begins to curve away beneath it. The stone is plummeting, but the ground is receding at the exact same rate. The stone never hits the grass. It never finds the centre. It continues to fall forever, and yet it never arrives. This is the honest truth of an orbit. It is not a state of floating. It is the art of falling towards something and being perpetually reorganized into missing it. This balance is fragile. It is a precise tension between two opposing desires. The gravity of the planet wants to pull the object inward. It wants to collapse the distance and bring the stone home. But the velocity of the object wants to carry it away. It wants to fling it out into the black silence of the void. When these two forces reach an agreement, you have a satellite. You have a moon. The object is trapped in a permanent state of free fall. If you were standing on that stone, you would feel weightless. This is not because gravity has vanished. It is because you and the stone are falling together. There is no floor to push back against your feet. There is only the long, curving drop through the dark. Most orbits are not perfect circles. They are ellipses. They are stretched. As a planet moves in its path around the sun, it does not maintain a steady distance. It drifts. At one point it reaches its furthest edge, known as the Fee, Li-un. Here the pull of the sun is at its weakest. The planet slows down. It lingers in the cold. Then the curve turns back. As the planet falls closer to the sun, it gathers speed. It accelerates, whipped forward by the increasing pressure of gravity. It screams past the sun at its closest point, the pay, Lee, before the momentum carries it back out into the deep again. It is a cosmic inhalation and exhalation, a slow rhythmic pulse that governs every moving thing in the sky. This same patient pull does not stop at the edge of the atmosphere. It reaches down. It touches the things we can feel. Consider the ocean. The moon is a cold, grey rock 250,000 miles away. It is small compared to the earth, and its grip is faint. But gravity does not need to be strong to be effective. It only needs to be constant. The moon does not pull on the earth as a single, solid piece. Instead, it pulls on everything differently depending on where it stands. The water on the side of the earth facing the moon feels the strongest tug. The ocean there begins to lean. It does not move like a wave crashing on a beach. It moves like a sheet of silk being lifted by an invisible hand. The water bulges toward the moon, stretching upward in a slow, silent swell. But the moon is also pulling on the earth itself. The solid crust of the planet is pulled forward, leaving some of the water behind on the opposite side. This creates a second bulge, a mirror image of the first. The result is two great mounds of water. They shift across the surface of the globe as the earth rotates beneath them. We call these the tides. But in the language of gravity they are simply the ocean leaning toward a rock. It is a rhythmic conversation between two bodies. The moon asks the water to follow it, and the water complies. It rises and falls with a clockwork precision that has not faltered for billions of years. If you stand on the shore at midnight and watch the tide go out, you are witnessing a planetary scale movement. You are seeing the earth turn away from the moon's gaze. The water is not simply leaving. It is being held elsewhere. It is responding to a command issued from a distance so vast that the human mind cannot truly map it. There is a profound stillness in this mechanism. We often think of gravity as a violent force. We think of the crash of a falling vase, the collapse of a star, or the crushing weight of a mountain. But here, in the orbit and the tide, gravity is something else. It is a suggestion. It is the universe's most patient way of keeping things together. The moon does not have to touch the ocean to move it. The sun does not have to hold the earth with a physical chain to keep it from drifting into the freeze of interstellar space. They only need to exist. Their mere presence creates the curve. Their mass carves the path. Everything in the solar system is simply following the slope of the land. However, the land is made of nothing but empty space and geometry. We are all just sliding down a hill that has no bottom. The satellites we launch into the sky are not defying this law. They are surrendering to it. We give them enough speed to miss the earth, and then we let go. We trust the math. We trust the curve. We place our communications, our maps, and our eyes in the sky. We know that as long as they keep moving they will never fall. They will continue their endless curving drop, circling us like ghosts in a machine of perfect precision. It is a quiet arrangement. A sequence of falls and misses. The ocean rises. The moon retreats. The planet turns, and through it all the distance remains exactly what it needs to be. For a long time we thought of gravity as an invisible string, a force that reached out across the void to pull one object toward another. It was a clean idea. It worked for the apple and it worked for the moon. But A. L. Burt, Einstein looked at the same universe and saw something different. He did not see a string. He saw a slope. He proposed that space is not an empty room where things happen. Space is a fabric. It is a physical thing that can be stretched, compressed and bent. When you place something heavy into that fabric, such as a star, a planet or a moon, it does not just sit there. It sinks. It creates a dip, a curve in the geometry of everything. This is the core of the correction. Mass tells space how to curve, and space tells mass how to move. If you roll a marble across a flat table, it moves in a straight line. But if you place a heavy lead ball in the centre of that table, the surface bows. If you roll the marble now, it will begin to circle the weight. It is not being pulled by a ghostly hand. It is simply following the curve of the floor. The marble thinks it is going straight. The geometry tells it otherwise. This shift in thinking changed everything. It meant that gravity was not something that happened inside space. Gravity was space. We do not feel this curvature in our daily lives. To us the ground feels flat, the air feels still, but the curve is there, acting on every atom of your body. It is a quiet, constant pressure. It is the reason you stay anchored to the earth while the world spins at 1,000 miles per hour. You are not being held down by a force. You are simply resting in the dip that the earth has made in the universe. This is an elegant theory. It is poetic, but it is also practical. You can find the evidence for this curvature in your pocket. Every time you open a map on your phone to find a street or a store, you are using a network of 24 satellites. These machines are orbiting high above the atmosphere, encased in gold foil and powered by solar panels. They are lonely sentinels, drifting through a vacuum where the temperature swings from freezing to searing in a matter of minutes. To tell you where you are, these satellites rely on time. Inside each satellite is an atomic clock. These are not gears and springs. They are instruments of extreme precision that measure the vibrations of atoms. They tick with a regularity that is almost frightening. They do not lose a second over millions of years. But because they are in orbit, they experience the universe differently than you do. There are two things happening to those clocks. First, they are moving fast. According to special relativity, speed slows time down. Because the satellites are racing through space at thousands of miles per hour, their clocks tick slightly slower than a clock on your nightstand. But there is a second, stronger effect. The satellites are far away from the mass of the earth. They are sitting in a shallower part of the curve. Down here, where you are lying still, gravity is stronger. That strength compresses time. It drags at the seconds. Up there, in the thinner gravity of orbit, time runs faster. When you combine these two effects, the result is a discrepancy. The clocks on the satellites tick faster than the clocks on the ground by about 38 μ/s every day, 38 millionths of a second. To a human this is nothing. It is a sliver of time so small it cannot be felt. But to a GPS receiver it is a catastrophe. The system calculates your position by measuring how long it takes for a radio signal to travel from the satellite to your phone. These signals move at the speed of light. At that velocity a mistake of 38 μ/s is not a small error. It is a distance. If the engineers did not account for Einstein's curve, the clocks would drift. The timing would fail. Within a single day the blue dot on your map would be off by 10 kilometres. By the second day you would be lost. Your phone would tell you that you were in the middle of a forest when you were actually standing in your own driveway. To fix this, the scientists do not change the physics. They change the clocks. Before the satellites are launched, the atomic clocks are intentionally tuned. They are set to tick slightly slower than a clock on Earth. They are programmed with an offset. The engineers essentially tell the clock to lie. They build the error into the machine so that once it reaches the curve of orbit it will tick in perfect synchronization with the world below. It is a strange thought. Our most advanced navigation tools only work because we have taught them to ignore the literal time of their own existence. We live in a world where the abstract math of a man in a patent office a century ago is required for you to find a coffee shop in a city you have never visited. The curvature of space-time is not just a theory for astronomers or a sketch on a chalkboard. It is a functional part of our infrastructure, on a chalkboard. It is woven into the silicon and the satellites. We move through these curves every day without noticing them. We trust the map. We trust the timing. We forget that we are drifting through a warped landscape, where time stretches and shrinks depending on how close we are to a heavy object. The universe is not a rigid grid. It is fluid. It is flexible. It breathes. And as you lie there now, your own mass is creating its own tiny infinitesimal curve in the space around you. You are bending the universe just by existing. It is a small thing, a quiet thing. But it is the same law that governs the stars. There is a planet that lives in the glare of the sun, Mercury. It is a small world, a scorched, iron-heavy sphere that moves faster than any other planet in our system. Because it is so close to the sun, its orbit is not a perfect circle. It is an ellipse. In every orbit there is a specific moment where Mercury reaches its closest point to the solar fire. This point is called the pair, Heee, Li Un. For centuries astronomers watched this point. They mapped it with ink and precision. They found that the Heee Li Un does not stay in one place. It drifts. As Mercury circles the sun, the entire ellipse rotates slowly. The orbit itself is turning. This is called Seth Yom. Under the laws of Isaac Newton, this movement made sense. The other planets, like Jupiter, Earth and Venus, all exert their own gravitational pull on Mercury. They tug at it, they nudge the orbit. When astronomers calculated these nudges, using Naya-ud-Din physics, the math was almost perfect. It accounted for nearly every inch of that drift. But not all of it. There was a remainder. A tiny, stubborn gap in the ledger. 43 arc-SEK-uns per century. To understand an arc-second, you have to imagine a circle. Divide that circle into 360 degrees. Then, divide one of those degrees into 60 minutes. Finally, divide one of those minutes into 60. An arc-second is one of those slivers. 43 of them over 100 years is an amount of movement so small it is almost invisible. It is a ghost in the data, a smudge on the lens. But for the astronomers of the 19th century that smudge was a crisis. They did not believe the math was wrong. They believed Newton was absolute. If the orbit was drifting more than the math allowed, they assumed the cause was physical. They assumed something was missing from the map. They looked at the gap, those 43 arc-SEK-uns, and decided there must be another mass hiding in the light of the sun. A hidden planet. A world that Newton's equations would account for, if only it could be found. They called this imaginary world Vulcan. For decades the search for Vulcan became a piece of cosmic bureaucracy. There was an exercise in filling a hole with a guess. Astronomers spent nights in cold observatories, staring into the blinding haze of the solar corona during eclipses. They looked for a tiny dot of light that would explain the discrepancy. They wrote papers. They debated coordinates. They tried to force the universe to fit the equation. They were not looking for a new law of nature. They were looking for a planet that did not exist. Vulcan was a placeholder for an unknown truth. It was a ghost created by the desire for order. The astronomers trusted their tools, but they did not realize the tools were built for a different kind of world. Newton's gravity is a beautiful thing. It treats space like a stage. A flat, empty void where objects pull on one another across a distance. In that version of the universe, gravity is an invisible string. If the string pulls too hard, you add more mass to the other end. You add a planet. You add Vul. Vulcan. But Mercury was not being pulled by a hidden planet. Mercury was simply moving through space that was not flat. The answer did not come from a telescope. It came from a change in perspective. Aelbert Eyen Stein looked at those 43 arc SEK Uns and saw something different. He did not see a missing planet. He saw a curve. He proposed that the sun is so massive that it does not just pull on Mercury. It warps the very fabric of the space around it. Imagine a heavy lead ball sitting on a trampoline. The fabric dips. It curves. If you roll a marble across that fabric, the marble does not move in a straight line, because it is being pulled by a string. It moves in a curve because the floor itself has changed shape. Mercury is that marble. It is orbiting so close to the sun that it is travelling through the deepest part of the dip. The space there is stretched. The geometry is distorted. When Einstein applied his new equations, the laws of general relativity, the 43 arc SEK Uns vanished. They were not a mistake. They were not caused by a ghost planet. They were the signature of curved space. The math finally closed. The ledger was balanced. Vulcan disappeared from the maps. It was not found and renamed. It was simply never there. It was an architectural error in our understanding of the void. It is a humbling thought. For years the most brilliant minds on earth chased a phantom across the sky because they were trying to protect a formula. They preferred a fake planet over a broken rule. They wanted the universe to be a clock. Instead, it was a fabric. The mystery of Mercury's orbit tells us that the universe does not always announce its secrets in loud, obvious ways. Sometimes the most profound truths are hidden in the smallest margins. A few arc SEK Uns. A slight drift. A tiny discrepancy that everyone else might have ignored. But those who pay attention to the margins find the cracks. And it is through those cracks that we see how the world actually works. We stop looking for the things we expect to find, and we start seeing the things that are actually there. The drift of Mercury was not a problem to be solved. It was a clue. It was the universe whispering that space is not an empty room, but a living, bending thing. And as we move away from the heat of the sun, away from the scorched plains of Mercury and the ghost of Vulcan, we find that this curvature is everywhere. It is not just in the deep dips near stars. It is in the very air around us. It is in the way time itself stretches and folds. And yet, for all its reach, gravity is a fragile thing. In the hierarchy of the universe, it is the weakest of the four fundamental forces. It is an afterthought in the mathematics of the very small. To understand this, you only need to look at a refrigerator magnet, a small ceramic disc, a thin strip of metal. When you hold that magnet over a paper clip, the clip leaps upward. It defies the entire mass of the planet. The earth, with its 6 sextillion tons of rock and iron, pulls the paper clip down. But the tiny magnet pulls it up. The magnet wins. It is a quiet victory, but it is absolute. It proves that on a small scale gravity is almost non-existent. It is a whisper in a room full of shouting. The electromagnetic force, the one driving that magnet, is orders of magnitude stronger. If gravity were as powerful as the forces that hold an atom together, the world would not be a place of soft breezes and drifting clouds. It would be a crushed, singular point of infinite density. We do not feel this weakness in our daily lives, because we live in a world of heavy things. Consider a cast-iron pan. It has a specific weight, a cold, dense presence in the hand. When you let it go, it does not drift. It does not hesitate. It accelerates toward the floor with a predictable, bruising certainty. When it hits, the sound is sharp. The vibration travels through the soles of your feet. In that moment gravity feels like the only law that matters. It feels dominant. It feels inevitable. But the pan only falls because there is nothing to stop it. There is no opposing force pushing the pan upward with a strength equal to the earth's pull. The pan is simply surrendering to the only force available. This is where gravity becomes unique. Most forces in the universe have an opposite. Electricity has positive and negative charges. They attract, they repel, and eventually they cancel each other out. A room full of electrons and protons can reach a state of neutrality. The tension vanishes. The energy settles into a quiet balance. Gravity does not work this way. There is no such thing as negative mass. There is no anti-gravity that pushes away. Gravity only ever pulls. It only ever adds. It is the only force in existence that is purely cumulative. Every single atom of matter in the universe, no matter how small, contributes to the total. A grain of sand has a gravitational pull. It is too small to measure, but it is there. A pebble has more. A boulder has more. Still, because gravity never cancels out, it can do something the stronger forces cannot. It can build. It starts with a cloud of hydrogen gas, cold and thin. The gas is mostly empty space, but every atom is pulling on every other atom. The pull is microscopic. It is almost nothing. But because there is no opposing force to stop it, the pull persists. The atoms drift closer. As they get closer, the pull grows stronger. As the pull grows stronger, more gas is drawn in. It is a slow accumulation, a patient gathering of mass. For millions of years this additive process continues. The cloud collapses, it spins, it heats up. The pressure at the centre becomes unbearable. And then the gravity has gathered enough matter to ignite a star. The sun is not powerful because gravity is strong. The sun is powerful because gravity is strong. The sun is powerful because gravity is patient. It took the weakest force in the universe to build the largest objects in the sky. We are held to the ground by a force that is, by all technical accounts, pathetic. If you can lift your foot off the floor, you have just defeated the gravitational pull of an entire planet. You are stronger than the earth. But while we win the battle for the inch, gravity wins the war for the aeon. It governs the shape of the galaxies. It dictates the curve of the cosmic web. It manages the slow rhythmic dance of binary stars circling a void. It does not need to be loud. It does not need to be fast. It only needs to never stop adding. When you look at the night sky, you are seeing the result of this singular additive nature. You are seeing what happens when a weak force is given enough time and enough room to work. The stars are not held together by violence. They are held together by an endless series of tiny, polite suggestions, every atom asking every other atom to come a little closer. But because there is no one to say no, they do. They gather in the dark. They cluster into spirals. They form the great architecture of the void. It is a quiet process. It happens in the silence between breaths. We spend our lives fighting it. We build skyscrapers to push against it. We burn millions of gallons of fuel to escape it for a few hours. We feel the ache in our joints and the pull on our skin as we age. A slow surrender to the downward draw. But there is a peace in that surrender. There is a comfort in knowing that you are being held. That the earth beneath you is not merely a platform, but an active participant in your stillness. You do not have to exert effort to stay here. You do not have to grip the world to keep from drifting into the black. The universe has already decided that you belong on the surface. It has spent billions of years arranging the mass of the planet just so it could hold you. The weight you feel is not a burden. It is an anchor. It is a quiet agreement. You do not fight the floor. You do not argue with the earth. You simply let it have you. But there are places in the dark where this agreement becomes something else, where the polite suggestion of gravity turns into an absolute command. Deep in the silence of distant galaxies there are remnants of stars that died in a particular way. They were too heavy to fade quietly. When their fuel ran out, they did not simply dim, they collapsed. Imagine a star larger than our sun, crushed down until it is no bigger than a city. All that mass, all that ancient fire, compressed into a sphere 20 kilometres wide. This is a neutron star. In these places gravity is no longer a gentle curve in the fabric of space. It is a cliff. If you could take a single teaspoon of matter from the surface of a neutron star, it would weigh billions of tons. It would be heavier than every mountain on earth combined. At this scale the rules we know begin to bend. The gravity is so intense that it does not just pull on matter, it pulls on light. A Foch-ton passing too close is dragged from its path. Space itself is twisted into a knot. On a neutron star there is no such thing as a soft landing. There is only the crush. The demand for density is non-negotiable. We will leave those heavy places for another night. We will let them spin in their distant silence, far from the reach of our breath. For now we return here, to this room, to this moment. Feel the points where your body meets the surface beneath you, the backs of your heels, the curve of your shoulder blades, the small of your back. These are not just points of contact. They are the places where the earth is claiming you. We spend our days fighting this force. We stand up. We lift things. We walk against the pull, muscles tensing to keep us upright and separate from the ground. We treat gravity as an opponent to be managed. But lying still is a different act. When you stop resisting, the tension leaves your jaw. It leaves your neck. It drains out of your fingertips. You are no longer fighting the curvature of space-time. You are simply following it. There is a profound relief in this surrender. You do not have to hold yourself up any more. You do not have to maintain the architecture of your posture. The earth is doing the work for you. It is pulling every cell, every atom, and every heavy thought toward its centre. It is the only demand the universe ever makes of us. Stay, be here, remain together. Listen to the rhythm of your own breathing, the slow rise of the chest, the long, steady fall. Even this movement is a dialogue with gravity. Your lungs expand against the pressure. Your heart pushes blood upward, fighting the pull for a brief second before letting it flow back down. It is a clock that never stops, a pulse that matches the rotation of the planet. Outside, the world continues its slow, heavy dance. The moon pulls at the oceans, shifting billions of tons of water in a rhythmic lean. The earth leans into the sun, tracing an ellipse through the void. Everything is falling, and everything is missing. The stars are falling toward each other. The galaxies are drifting. The entire cosmos is a sequence of things finding their place. You are part of that sequence. You are not floating in a void. You are held. There is no need to worry about the distances between the stars or the crushing weight of dead suns. Those things are far away. They belong to the mathematics of the deep. Here gravity is kind. It is the warmth of a blanket. It is the stillness of a room at midnight. It is the knowledge that you are exactly where you are supposed to be. You do not need to hold the universe together. You do not need to balance the equations or steady the orbit. The laws are already in place. They have been working since the first atom gathered its strength. They will continue to work long after the lights in this room go out. The weight you feel is not a burden. It is an anchor. It tells you that you are real. It tells you that you are real. It tells you that you belong to this world. Let your thoughts become heavy. Let them sink. One by one let the details of the day drop away, the conversations, the lists, the small anxieties. Let them fall like stones into deep water. They do not need to be carried any more. The earth will take them. There is nothing left to do but exist in the pull, to feel the slow steady pressure of being known by the ground. The air in the room is cool. The silence is thick. Your body is heavy. Your mind is quiet. You are a small piece of matter in a vast curving dark. And for tonight that is enough. Close your eyes. Let the anchor hold. Let the world turn. Just drift.